Hi, this video will cover setting up a first project in Microchip Studio to program our Arduino with a program to blink initially an LED on the Arduino and then set up a breadboard with an LED and blink the LED on that. So to get started, I have the guide here to go through for programming an Arduino. As we go through the steps here, I've already installed the Arduino IDE using the Win 7 newer version. So I've been through all of this. The Arduino IDE runs. Now I need to know what COM port my Arduino will come up on here in ports under Device Manager. So I'm going to plug my Arduino in. Okay, and now to launch Device Manager, I already have it running, but if I needed to launch it, you can just start typing Device Manager in your start menu, and then click on it here, and it should open it. So here under Ports COM and LPT, I see Arduino Uno is coming up on COM 3. I just need to remember that number, that it's on port COM 3. I'll leave this window. I'm just going to shrink it down. All right, so then we come down and we need to set up AVRDUDE. That is the tool that's going to program our Arduino after we build in Microchip Studio. So I'm going to set that up here in File Explorer, and I'm going to set that up to make it easy for myself. I'm going to put it right here on the root C drive. I'm going to create a new folder, and I'll just call it AVRDUDE. And then I need to go find the files that I'm going to copy into them. So they should be in Program Files, x86, Arduino, and then Hardware. And this is all in this document. It told us to create the folder, preferably here, right on the C drive, or in your username documents. You shouldn't be doing this on a Mac right now. Here it's telling us where to find the files, so I'm just following that path. So Program Files x86, Arduino, Hardware, Tools, AVR, Bin, and in here we should find the AVRDUDE exe file. So there it is. I'm going to copy that. And choose copy. And then I'm going to go back here to the root C drive and AVRDUDE, and I'll paste that here. All right, now I have one more file to go, so I have to go back to the root C drive, to Program Files x86, Arduino, Hardware, Tools, AVR, and this time I need to go into this etc folder and grab a copy of this configuration file. Remember, if you're not seeing these extensions, just go under View and check the file name extensions box. All right, so I've got a copy of that. I need to go back. I'm just going to use the up arrow to keep going back to the root C drive. All right, there's the root C, there's the AVRDUDE, and I'm going to paste that here. All right, so my path will just be C:\AVRDUDE to get to these files. All right, so we go back here. We've set up our AVRDUDE folder. Instead of under users and all, we have it right on the C drive. You can set it up in your documents folder. You're just going to have a longer path to use later. All right, so now to set up an AVR programmer. Well, before I can do this, I need to get a new project started in Microchip Studio. So I have Microchip Studio running, and I'm going to start a new project. And this will be an assembler project, AVR assembler. I'm going to call it Blink LED. And I don't like this path. I'm going to just get rid of the Atmel Studio and 7.0 and change that to projects. And it'll create that folder for me and then create Blink LED inside of it. And then I don't want a separate directory for the solution. So I'm going to uncheck that and say OK. All right, for device selection, our Arduino uses the AT-Mega 328, and we want the one without the P because this has the better include file, the more inclusive include file. So I'm going to say OK. All right, now that we have our new file, this is a brand new install of Microchip for me, so I've got a bunch of extra windows, so I'm just going to close some of them just by clicking their text. I want the Solution Explorer. Most of these other windows I don't want, and they're just going to be distractions. I'm going to close them. So I have the main ASM file for my project open. I'm going to rename that to be all lowercase. I'll just call it blink.asm. I'm going to, or I'll keep it the name of the project. Sorry, my virtual machine is having fun with my, I'll just change this here to blink.asm. All right, that's the name of my file. The purpose of this is demo general purpose I/O by blinking and LED. Okay, author here is Azul, our mascot. Let me get rid of this. And then let me make sure that this is set up. I'm going to go to Tools and Options. And then I'm going to come down to the editor, the text editor. And for assembler, first I'm going to click on General so I can see line numbers. And then on the tabs, I want 5, 5, and insert spaces. All right. So right now, before I start writing my code, I'm going to finish the programmer part. So I need to build this external programming tool, and mine was on COM3. So you'll see we can build one of these for each COM port that our Arduino tends to come up on, because it can change from time to time. And we just have to edit this path down here that we see, this arguments, to have which COM port and then where our AVRDUDE is. So you can either keep editing it and only have one of these external tools built, or just create another version of it and change the COM port. So we'll see that. All right, so I'm going to start here, back here in Microchip Studio under Tools. I'm going to click on External Tools, and then I'm just going to start naming this. I'll call this Arduino 3. And the command, I can actually browse. So if I click this browse on my root C drive in AVRDUDE, our command is avrdude.exe. So I can say open, and that's arguments, I need to go back to this document. So I am going to copy this string here, copy that, and I'm going to first open Notepad. I don't have a whole bunch installed on this. I have Notepad++, I'll open that. The regular Notepad would have worked. No, I don't want an update. Let me close that update message if I can find it again. There we go. So I'm going to paste that string, maybe. There it is. And then I just need to change this path. This path was C:\AVRDUDE. AVRDUDE. All right, and then that's where it'll find the configuration file. And then over here, I need to replace that with COM3. And then I want to make sure I select all this to include that I at the end and that -C at the beginning. Sorry. And then I just need to go back to the window and paste that in the argument. So back in Microchip Studio, I just need to paste that here and say apply. And then I can do, I'm going to check this use the output window. And that way, when we do programming, we'll see it show up down here in the output window. Otherwise, it opens up a separate terminal window and then it goes away afterwards. But I want it to show up down here when I do my programming. We can see now under Tools, we can see Arduino COM3 is now set up as an external tool. All right, so let's write our program to blink our LED. I am going to start with a main, and then I like to do an end main label with an rjump back to end main. And then I am going to need to call a delay routine. So I'm going to set up the delay routine first. I'm going to come down here below main. I can do this. And I'm just going to set up a real quick. We're going to go very light on commenting and everything on this demo example. But we're going to do a delay one. Let's just call it delay because then we can adjust it some. So we need our 3 nested loops to create a looping delay. So I am going to first, I need to set the outermost control variable loop counter. So we need an LDI, and I'll just use R22. I'm going to use R22, 21, and 23, or 22, 21, and 20. So I'm going to do 64, and then I need a label. This will be, I'm going to call this delay. Call this delay 1. And then inside of that loop, or at the end of that loop, the bottom of that loop, let's call it that, we'd be decrementing R22 and branch not equal back up to delay 1. And then at the end of our routine, we need a return, and this is the end. Oops, go to column 31. This will be our end delay. Right, and then inside of here, I want to set my next control variable for a loop counter, and this one will be for 200. And then we need a delay 2, and this will need to decrement the R21 control variable and branch not equal to delay 2. And then inside of that, we need to set another control variable for R20, and we'll set that for 250. And then delay 3. And once again, we need to decrement decrement R20 and branch not equal to delay 3. And then inside of here, we just needed to waste 5. We need 5 repeatable instruction cycles. Our decrement was 1, our branch is 2, so we need 2 more. So we need our 2 no-op. All right, so this represents our 5 instructions times 250 times 200 times 64 should give us our 16 million running at a 16 megahertz clock. This should take 1 second right now. We can come back in here and adjust this later to speed this up. So we can see our blinking will run at different rates. All right, so just real quick, I'm going to create a little comment line here that goes out to about column 60. And I'm looking down here in this bottom down here for the column. And I'm going to use that real quick just so I see where this delay routine is. And I'm going to do delay 4 seconds. All right, and that way I can tell where that delay routine is. All right, so now up here, to be able to call this delay so that we can return to it, I need to set up the stack. So let's do our stack. We can use R16 as a general purpose register, and we need to get the high of RAM end, which is our 08FF address. And we want to write that out to the stack pointer high register. And then we can use our 16 again to get the low byte of RAM end, the address, and we can write that out to SPL. All right, so that'll set up our stack so that our stack is good for using the call instruction. All right, now, as we covered some of this in our lecture, so we just want to be able to turn on a port, and we're going to use port B pin 5. So first we need to set that pin in that port to be in an output direction. So we need to modify the direction register for port B. So we're going to do a SBI to set a bit in IO in port B. I'm sorry, this should be the direction register. DDRD for the data direction register for port B, and we want to set DD5. That way we're setting pin 5 of the data direction register. Right, so this will set DD5 to output. All right. Now we're going to have our repeatable program processing. So let's just call it blink. And here, what we want to do is we can start by turning PD5 on. So to do that, we want to set its voltage high on the output register. So SBI this time to port B is the output register. And then we would just use PD5. This would be to turn the LED on. And then we want to delay, so we can call delay. All right, now we want to turn it off. CDI to set that pin low on port B, PD5. Oops. Turn the LED off. And then we want to delay again. So we have that 1 second where the light is on, and then a full second while the light is off before we turn it back on. Otherwise, it'll just look like it was on steady. Right? And then here we can just jump back to blank, which means we will never actually get down to this end main. This is just habit to always put that there. Right? But that should start a nice blink rate for us on port B pin 5. So I'm going to do a build. All right, and it succeeded, and now I should be able to program my Arduino on COM3. So I'm going to do Tools, Arduino COM3. We see it's communicating with the board, and it says it's done. And if we look on the board, it's very light here, but you can see the LED is blinking, and it's blinking at about a 1 second delay. So let's adjust that delay, because if your default board probably already had a blink routine on it, so it may have been blinking anyway. So let's make this go a lot faster so that we can confirm that we're the one that's actually driving it. So we should be able to get this down to a half a second delay just by dividing this first number in half from 64 to 32. And that should get us to 8 million times our 0.0625 should be 500,000 microseconds, which will give us our 500 milliseconds. Would be 500 microseconds or 500 milliseconds. This was just to give an idea of it. We're not really controlling it this way. All right, but let's do a build. So we should be blinking twice as fast now, so we can still see the rate that it's blinking, the 1 second delay here. And now when we do it did a build, here I did a build, now I'm going to do the programmer. I'm going to do the Arduino programmer. We'll see it communicate with the board. And now we can see it's blinking now at about a half second rate. So we can see it's blinking quite a bit faster, so we know that we controlled that. And so everything's good. All right, so let's see what it would be like if we attach this to a breadboard with an LED. Okay, we're going to build a simple circuit using our Arduino and our breadboard. The circuit I have shown here in Wikipedia is showing us a voltage source with current going to the anode. That's the positive side of the LED, which should be the longer leg, and then through to the cathode, the negative side of the LED, or the shorter leg, through a resistor back to the Arduino. So we'll come from an input pin, which will act as the voltage source, back around to the ground on the board. So it'll be just a slightly different type of circuit. I've got some of the components out here. I've got a red LED. You can kind of see that one leg is longer than the other, so the longer leg is the anode and the shorter leg is the cathode. I've got a couple wires. I'm going to use an orange for the input pin and then the black for the ground. The only thing now I need is a resistor, and the kit that I grabbed to demo this, the LED, usually these pieces of paper have the ohm rating of the LED, and this kit did not. So I'm having to do a little bit of investigation. I've got my color card. Based off what I want, if we look at a calculator real quick, I need to keep an LED current down to 20 milliamps or below, or I'll end up burning most LEDs. So that's a key value. We know we're starting from 5 volts in the pins of the Arduino. And if I look at a color chart here, I can see a red LED is normally like 1.63 to 2.03 volt, has a voltage drop of that. But usually a rough number is 1.7 volts. So we can use 1.7 volts as our voltage drop, or our forward voltage across the LED. So that means we have 5 minus that 1.7. And that's going to give us 3.3. Now, if I divide that by the 20 milliamps that I want, so that's 3.3 volts divided by the 0.02, milliamps. That means I need a resistor not lower than 165 ohms. I might have a 100 ohm resistor. I probably don't have 165. So the next number up is usually going to be 220 and then 330 and all that. So if we look at that again real quick, if I did my 5 volts minus 1.7 volts, that leaves me with 3.3. If I divide that by a 220 ohm resistor, that means I'll only be at 15 milliamps, so well below the 20 milliamp limit. So that's a good number to use, 220 ohm resistors. I just have to find a 220 ohm resistor. Looking at my card, it's saying here that if let me see which way this works out best for you guys. If I look at the numbers here, the first digit over here, 220 would be a red, black, so 220, and then 220 times 100, or 220, no, so it'd be black again, so 220 ohms. So I need to find that. Looking at these, it's very hard to read, but I can use a magnifier and kind of see the one that's further. One of them is orange, so that's going to be a 330, and the other one is red, black. So I think if I move this one out of the way, I believe that one is the red, black. I know it looks somewhat orange under this lighting, but it looks more red to me. So I'm going to pull one of these resistors. Remember, resistors don't have an anode and a cathode. We don't have to worry about polarity on those. All right, so what I'm going to do is I'm just going to put this resistor, I'm going to connect it to the ground rail. So one of these blue rails over here, and then I'm going to put it somewhere on the breadboard in like column 20. And sometimes it can be a little tough getting them in. I tend to use a small pair of needle nose pliers, which helps me kind of force them down into the breadboard. All right, so I've got that resistor. It's into the blue ground rail here, and then I have it in the second hole here in row 20. So now I'm going to take my red LED, which fell down, and I'm going to take the short end, which is the cathode or the negative side, and I'm going to put that in line with 20, and then just wherever the long edge goes down, I just need to make a note. So I've got the short end here going into row 20, in line with the resistor. And then I have the anode, or the long one, it'd be in 20, 21, 22, probably 23. All right. So that means that my cathode is in the same row as the resistor, and then the resistor is going into the ground rail. And then my anode, or positive one, is in this terminal row here. And I can zoom in on that in just a minute. Let's see if I can. All right, so we can see a little bit better now. You can see the resistor is in the ground rail, and then it's in row 20 here. And then the LED, the cathode, or the short end, is in that same terminal row 20. So it's connected to the resistor. And then the cathode, the positive side, is up here just a couple of rows in terminal 21. that same row, row 23. And so we can see it is now in the same terminal as the positive side of the LED. And then I am going to run that into the board where port B pin 5 comes in. And to see which pins are what here, we can go out to the Arduino.cc website and go to hardware. Sorry, my virtual machine here is running very slow. Okay, and then come down and find, oh, I'm sorry, we wanted documentation. We want to go to documentation and go to the Arduino docs new. We could have gotten to it through hardware, but the documentation link is. I'm going to scroll down while it's loading and find the Arduino Uno R3, which is the board we're using. And then I just want to pin out. So I'm going to click on this pinout here, and we should get the pinout image, and I can zoom in on it, but I'm looking for port B pin 5, which we can see up here in this top right corner, which is D13. And if we look over at our Arduino, we can see 13 is right here. So we can see the 13 on the board here. And right next to it is a ground, a GND. So we can use that ground as well. So I'm going to take the orange wire and put it into that 13. And then I'm going to take a black wire and put it anywhere in the ground rail. It doesn't really matter where. I'm going to put it somewhere in the ground rail and then put it into the ground right next to that 13. Huh. Wow, this Arduino, the ground is really hard. There we go. All right, I was struggling a little bit. My this breadboard that came with this kit that I'm using is not working very good. The ground rail isn't working very well. So what I've done is I've just made a slight change, and my LED, the cathode or the negative side is still in row 20 with the one side of the resistor. I've moved the other side of the resistor to row 15. I still have my orange wire going into row 23 with the anode or the positive side of the LED. So there, here the anode of the LED and the orange wire are in row terminal 23. And now I'm just going to take my ground wire, my black wire, which has gone into the ground on this side, right next to the orange wire in port B pin 5, and I'm going to put it in terminal 15 with the resistor, and we can see the LED is now blinking at the same rate as the one on the board. Right, so that's just demonstrating the same port that was on port B pin 5 is also the same as pin D13 on the outside of the Arduino out here. So to test that, we can do another one just real quick as a last test. If we look back at our pinout, let's say we wanted to use port D pin 5. So that would be pin D5. So let's remove the ground on your board first because that's safest, is to have the ground disconnected before you make any changes. All I have to do is pull the orange wire out of port B pin 5, and let's put that on pin 5 here, or port D pin 5. I've got that in D5 on the board. All right, I'm going to leave the ground disconnected, but I'll need to connect it back to this row 15 in a minute. But back here in our program in Microchip Studio, all we're going to do is make the changes here. So instead of port B pin 5, we're going to make this port D pin 5. It'll let me. Okay, too many D's there. So now we're doing the direction register for port D, and we want this to be DD5 for D5. This will be set, let's just say LED to output. And then down here, when we do the set bit, we need to set port D to D5. And then same thing when we clear it, port D, D5. Save that. So just confirm direction register D for DD D5, data direction D5, port D pin 5, and then port D PD5 and port D PD5. So I'm going to do a build. All right. And then I'm going to go back to tools and do Arduino COM3. And it's best to have the ground disconnected when you're programming the board so that there's no load from an external circuit during programming. All right, so notice our port B pin 5 LED is not blinking anymore. It's actually steady, which is fine. But the program is not trying to blink it anymore because we're not setting and clearing port D pin 5. If we plug our ground wire back into terminal row 15 with the resistor, though, we notice that our LED should be blinking again because current is now flowing from the input pin on port D pin 5 here on the Arduino through the orange wire, through the cathode of the LED, to the through the anode to the cathode, the negative side, then into the resistor, across the resistor to the black wire, which feeds it back to the ground on the Arduino. Right, so there's our demo program to blink an LED with both using the one on the board and using an external circuit